Hi everyone, this is Huiyuan Chen from Visa Research. Today I'm going to talk about our recent work about the top, bottom, and shoe, how to building a capsule wardrobe with cross-attention tensor networks. And this is a joint work with the Yusan, Fei, and Hao in the Visa Research. I think there's one unique property in fashion recommendations is trying to understand the visuals or the aesthetical compatibilities among different objects. And also there's a report says that on average, I think there's 36 times people may struggle to pair items together from the wardrobes to just form an outfit. And another study also showed that women might try as many as 20 pairs of jeans before making a decision. So this is sometimes the fashion recommendations is quite important for nowadays, especially for the shopping. There are a couple of challenging for the fashion recommendations. I think the first one is called the multi-item compatibilities. And like we have a head, top, bottom, shoe, bed, and how to puzzle them together to formulate as a fashionable outfit is quite challenging. In the left-hand side, we show that sometimes we might compose different items into a bag compatibilities. Or sometimes we might formulate different outfits and it has good compatibilities. And another challenging is that how to explore the visual signal in both local and global ways. Given an image, given a clothes, I think in addition to the global information like the colors, original colors, we still have a lot of details in these clothes. Like there's a black jack, or there's a bag, or syndrome from C. So how to design a machine learning models to capture this like region-wise information is also quite interesting and very important for the fashion recommendations. Another challenge is called scalability. I think there are billions of the clothes online, and how to design a faster and cheaper machine learning to models to deal with this kind of like large scale dataset is also a quite challenging task. And this is our models. We're trying to propose a method called a TensorNet. And in this study, we only focus on the top, bottom, and shoes. But I think it's very easy to extend to multi-items like the head, top, bottom, shoe, and bed. And this is how we're going to formulate data. So in the training data, we have a top one, top, bottom one, and shoe one. And we still also have a Huiyuan labels to tell us that if this triples has a good compatibilities. And similarly, we have like different kind of the training data doing different kind of triplet, like top two, bottom two, and shoe two. And still we also have a labels. And this is how we organize the training data. Basically, it's a classification problems like giving triplet, and we also have a labels to demonstrate if this triplet is good or bad. And in the inference time, so given a new quantity triplet like the top eye, bottom eye, and shoe eye, and we're trying to using our models to predict if this triplet is a good or bad compatibility. So this is our goal. And this is also another way how we organize the data. So given any wardrobe, we just pour all the items and make some arrangements to the top, bottom, and shoe. So for a top category, we have a multiple items, and similar for the bottom and shoe. And then we construct a third order tensors. So a tensor is nothing, it's just a high dimensional matrix. For example, in this case, in one of the mode of the tensor is all consists of the shoe. And the second mode is the bottoms, and the third mode is the top. We're trying to construct this three order tensors and design some of the machine learning algorithm, like in this one is TensorNet. And after we just do some tensor complete algorithm, and we're trying to predict if these items have a good compatibilities or any combinations of a triplet. Like we just pull out any top, bottom, and shoe and just formulate as a triplet, and we just using our algorithm to detect is this is a good compatibilities or not. So basically, this is how our algorithm works. And I think our proposed TensorNet consists of the four components. The first component is called a region-aware feature extractions. that we mentioned previous. I think a clause contains reason-wise information and how we're going to extract these features is all a key task for facial recommendations. And the second pass is called a cross-attention message passing for the pass. So consider alpha always consider the top, bottom, and shoe, and we also consider how messages be passing between the two neighborhood objects. I mean, two neighborhood object means that the top and bottom and shoe. So we're trying to consider how the visual signal will be passing from these two neighborhoods. And we also design some of kind of like the visual gate units. We're trying to filter the iterative signal, or we're trying to filter out the negative visual signal be passed across two different objects. The first three modules is trying to capture the local compatibilities between any two neighborhood objects. And finally, we also design web and deep tensor networks. So we're trying to capture the global compatibilities for an entire outfit. I mean, entire outfit means that we're trying to measure the compatibilities for the top, bottom, and shoe at the same time. And basically, this is our architectures. It's quite straightforward. I think in the bottom layers, we have an original image, like a top, bottom, and shoe. And we're using some of like the pre-trained ResNet to pull out the middle layers of the ResNet, and then we can get the reasonable feature information. And after that, we just consider the human part of the outfit, like a top, bottom, and shoe. And if the top, we consider the top and bottom and how to the message be passing between this top and bottom. So for example, in the figures, we using kind of like the cross-attention message passing. So like this one, we just pass some of the information, visual information from the bottom to the top. But then sometimes it might pass some of the negative signals from the top and from the bottom to the top. So we also design some gate fusion techniques to figure out those kind of iterative signal or called a negative signal. Yeah, and we also add the residual net to keep the original features of the top, and then we're just using some pooling layers. Similar for the bottom and shoe. So I think the bottom is in the middle, so it can pass the message to the top and the shoe at the same time. And the other architecture is quite similar to how to measure the cross-attention message passing. And this way, because the top and shoe, they are far away from each other, so we don't do the message passing between these two objects. We kind of like leaving some of our flexibility to choosing the top and shoe. This is basically our framework. And I think in the prediction layers, we also have a wide and deep tensor networks trying to measure all of the comparabilities between the top, bottom, and shoe. So it's at very high levels. We're trying to capture the global views of in entire outfit. Yeah, and I think wide and deep tensor is nothing. So we have a wide layers and deep layer. The wide layer is just kind of like the dot products. So we just using one layers of neural networks to capture the top, bottom, and shoe. And we're also using a deep networks, like it's nothing, it's just a simple deep neural networks to capture the more complex feature interactions between top, bottom, and shoe. And after that, we just time a trainable way and using a sigmoid functions to get the final result. And this is our dataset. So we choose for polyvores and iterations. I think these two become a benchmark for our facial recommendations. And this is our result compared to some of the matrix and tensor models. We're using the matrix heat and NDCG. So this is a two common matrix for the top K recommendations. As we can see, our models perform the best among different kinds of the matrix models or the tensor models. And this is basically our work. I think in this work, we try to design some of a normal ways how to deal with the multiple clothes together, and like top, bottom, and shoe. And we also consider the message passing in the visual part, like the top, bottom, and shoe. And finally, we also design a wide and deep tensor networks to deal with this kind of like the global capabilities of the entire outfit. And thanks a lot. So if you have any questions, feel free to email me. Thank you so much.